Hello. We're going to work on 6.2, Model Quadratic Relations. Today is Wednesday, June 3rd. Note number 1. Linear equations look like y equals negative 3x plus 2. There's a y here, okay, with a 1 as the exponent, and the x here, so 1 is the exponent. Or 5x plus 7y minus 9 equals 0. So there's an x here with a 1 as an exponent, okay? And the y here has a 1 as an exponent, okay? So for each linear equation, the exponent of y is 1 and the exponent of x is 1, okay? So you have y to the 1 and you have x to the 1, okay? Quadratic equations look like y equals 7x squared minus x plus 4, where the y has an exponent of 1, the x squared, okay, x has a 2, exponent of 2. There's another x here, but it's got a smaller exponent of 1. Or another example is y equals x squared plus 1. Y has an exponent of 1. X has an exponent of 2. There's no other x exponents, okay? So what makes this example and this example the same is it follows this rule. For each quadratic equation, the exponent of y is 1. Okay, so exponent of y was 1 here in this example and here. And the largest exponent of x, is 2. So in here, x had an exponent of 2. It also had an exponent of 1, but the largest exponent for x was 2, right? Because 2 is larger than 1. In the second example, x has an exponent of 2, okay? And it didn't have any other x's, so we didn't have to worry about whether it was largest or not. It was just the only one, okay? So an exponent is something that hangs in the air, okay? And it's above the other variables, okay? And it's like in a little cloud, okay? So using the guess method, determine if each relation, now the word relation can also be thought of as the word equation. So for each quadratic equation or relation, okay? For each linear equation or relation. So determine if each relation is linear or quadratic. How do you know? Okay. All right. So we're using the guess method. All right. So what are we given? We're given y equals negative 9x minus 11. The unknown is the relation linear or quadratic. Is relation linear or quadratic? Okay. E, the equation. Well, the equation this time is a rule. Okay, so this is a rule. Okay, and this is a rule. Okay, so we're going to follow the rule. So rule 1, we could call it rule 1, and we could call this rule 2. So rule 1, if we have y to the 1 and x to the 1, therefore relation is linear. Okay, so that's the rule that we're talking about up here. Okay, rule 2, if we have y to the 1 and the largest exponent of x is 2, and the largest exponent of x is 2, therefore relation is quadratic. Okay? All right. So in the solution space, we take the equation, which are the rules, the unknown, and the given. Okay, start with the given. Y equals negative 9x minus 11. Okay, so the y has an understood exponent of 1 there. Okay, and the x has an understood, if you can't see the exponent, it's understood to be a 1. Okay, so our solution then, so therefore, since we have y to the 1 and x to the 1, therefore the relation is linear. Okay? All right. What about the next one? So GUESS. All right. So we have been given y equals 5x squared plus 8x. The unknown is relation linear or quadratic. Okay? All right, equation. Well, it's more of a rule. Okay, so if we have y to the 1 and x to the 1, therefore relation is linear. Okay, the next rule is if we have y to the 1 and largest exponent of x is 2, therefore relation is quadratic. Okay, so then here, okay, our solution here, take what's the equation, the unknown, and the given, and in that solution we have y equals 5x squared plus 8x. Okay, so we have y, the exponent is understood to be a 1 there. Okay, we have an x to the 2, okay, in the air. Okay, so x is to the 2. We also have an x to the 1, okay, but the exponent of 2 is larger than the exponent of 1. So it follows the second rule. If we have the largest exponent of x is 2, then it's quadratic. So then we can say, since we have y to the 1 and the largest exponent of x is 2, therefore the relation is quadratic. Okay, so when we say, the question actually is coming from the textbook, how do you know? Okay, that was what they're asking you, because you're telling them since these things have been seen, okay, that's how you know the relation is quadratic. Since we have these things, okay, we know that the relation is linear. Let's go to the next one. All right, so we are given y equals 4x, and the unknown is relation linear or quadratic? Okay, so the equation is more like a rule, remember? So if we have y to the 1 and x to the 1, therefore relation is linear. Okay, another rule, rule number 2, and if you want you can label them, rule 2, rule 1, if we have y to the 1 and the largest exponent of x is 2, therefore relation is quadratic. Okay, so then the solution is to take the equation, the unknown, and the given. Start with the given, y equals 4x. Okay, so y is understood to have an exponent of 1. If the exponent's not written, it's in the air, right? If it's not written, it's understood to be a 1. X has an exponent. If it's not written, it's understood to be a 1. So it's in the air. So exponents are in the air. Okay, and notice it's always the letter X, and then it's always up to the right. Okay, so based on that, since we have y to the 1 and x to the 1, okay, therefore the relation is linear. Okay, so how do you know? Because of this, right? So the answer to the how did that you know question is what you say when you say since, right? So this is the proof. All right, note number 2. You can use Desmos, okay, to graph a set of data. So when we were in class, we used our graphing calculators. We're not in class, we don't have the graphing calculators, but Desmos will help us when we don't have graphing calculators, okay? So we have to have these two things in mind. When the points curve in a smile or a frown, these points represent a quadratic relation. So if the points smile, they look like this, right? Or if the points are in a frown, right, they go like this, okay? So if you have a smile in the shape of these points or a frown in the shape of these points, you have a quadratic relation, okay? When the points follow a line, these points represent a linear relation. So they could go like this, right? Or they could go like this. Okay, these two examples would tell you that you have a linear relation. Okay, so we're going to read through the example and then we're going to talk about Desmos. So example 2, using Desmos, graph each set of data. The data is here, okay, in your table. Describe the type of relation that best represents the data. So steps using Desmos. So we're going to go over here. Picture, our computer. Oh, don't want that. I want, there we go. Okay, so we're going to start from scratch. So I'm just going to clear, leave site, yes. All right, so our paper says, steps for using Desmos. Google Desmos and click start graphing. So we're going to Google Desmos. Oh, it took me right to Desmos. Let me show you what happens. Desmos. I want to take that away. So just Desmos. And then I'm going to click the first one. And I'm going to click start graphing. So that's step 1. Okay. So then step 2 says, click the plus symbol in the top right corner. So the top right corner is here. Click the plus symbol. Okay. And then it says, then click on the table icon. Okay, so the table icon is right here. Right? Okay, then what's next? It says type in the first x value, press the arrow down button to move down the table of values to type in each x value. So what does that mean? So the first x value is -3. So I'm going to use my keypad here, -3, and then I'm going to press the arrow down button like that, and it's going to move me down. Okay. Then I'm going to go to -2. Type in -2. Okay. Press my arrow down button. And then it moves it down. And I'm going to type in -1. And then the arrow down button. Then I'm going to press 0. And I'm going to press 1. So you can see, right? My x values, -3, -2, -1, 0, 1, they all match. Now my job is to type in the y values. The instructions say, number 4, press the right arrow button and the arrow up button to move to the top of the y column. So I'm going to press this button here, and then I'm going to press this button here. So watch when I do that. Press the right button, and then I have to press up, 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 and then I'm going to type in all of these values here. So it's A, right? And all of these values, after I type in this one, I have to press my arrow down button to type in this one. Okay, so I'm going to go -2, arrow down button, 1, arrow down button, 4, arrow down button, 7, arrow down button, 10. Oh, there we go. What do we see? Do they line up? Let me see if I have a ruler here. They definitely line up in a ruler. Okay? So then I would say, now my paper, since, it's just sort of hard, since points lie in a line, therefore relation is linear. Oopsies. Okay, not very good, but that's okay. All right, so I don't need these points anymore, so if I want to get rid of them, I just use my delete button. So delete, arrow up, delete, arrow up, delete, arrow up, delete, arrow up, delete, arrow over, button, delete, arrow down, delete, arrow down, delete, arrow down, button, arrow down, button, okay? So then I go back up and I'm starting now for question B, okay? So 0, 1, 2, 3, 4. Every row is a opportunity to press your arrow down button. So 0, 1, 2, 3, 4, and then up, up, up. And then the button or the numbers are -4, -1, -4, -1, 0, 1, and 4. I think I'm going to have to fix that. I want these to be negatives. I'm going to fix this for us. I'll make sure I fix that. So -1, -1, -4. Don't worry, when you get the sheet, you'll have a fixed copy. Okay, so what happens to those points? Well, those points, where's my cursor? I've lost my cursor. Well, I'll show you with my finger. So see, it goes up and down. That's in a frown, right? Up and down. It's in a frown. So my paper. Since points are in a frown shape, therefore the relation is